All right, we're recording, so we're live. All right, y'all do these two problems. This is last class, so y'all can't say, oh, I don't know how to do them. I knew somebody was going to say that. This is from the last class. Oh, we don't have to come anymore? I knew that was coming. I was just waiting for it. Y'all know how to make a guy feel great, you know? I'm supposed to be impressed with my little grids up here that I found. I'm just got it offline. You can go online and print these off and make copies where you don't have to draw a bunch of graphs. Well, just in case you get confused, first thing you do is you draw what? Draw a little table. Y'all should remember this from doing homework over the weekend. No comment. Now, what's the four numbers I'm going to pick for this one? -2, -1, 0. It's supposed to be a 0. 1 and 2. What am I going to pick for this one? No. What? What we got in this one? What is that? A fraction, which means it has a denominator. 10% of the time, you're going to use multiples of the what? Read your page. 10% of the time, what are you going to read down there toward the bottom? Multiples of the denominator. -4, -2, 0, 2, and 4. All right, plug and chug. Hey there. So, -2. I'm not writing all that. The mouse just takes too long. -2, parentheses, -5. -2, parentheses, -5. -2, parentheses, -5. -2, parentheses, -5. And one more time. -2, parentheses, -5. -2, -1, 0, 1, and 2. What's the 0? All right? What's -2 times -2? -4 minus 5? -9. -3 -2. That's wrong. It's not negative. Y'all told me wrong. What's -2 times -2?
-4.
What's -2 times -2? Positive 4. 4 minus 5 is?
-1.
What is -2 times -1?
2.
2 minus 5?
-3.
0 minus 5?
-5.
Now what's the pattern? -1, -3, -5, -7, -9. Let's check it. -2 times 2 is -4. -4 minus 5 is? Then plot your points. Go ahead and plot your points. Where?
Why is that -2? Yeah, what's in the -2? It's +2 with -5.
Okay, change it. Because I'm not going through and changing it. I'm sorry. Y'all just have two problems to work now. 2x minus 5 and -2x minus 5. I ain't changing all that. I don't know where it came from. I guess I just made it up.
It's like you were starting to do it right, -9, -5.
I don't know. Don't ask me. I don't know. I just went from 2x minus 5 to -2x minus 5. I don't know where I got it. I'm just ready to quit. I know, live in a ditch. Go to Kentucky Fried Chicken and get me a little cardboard laptop, and I can just sit there and play on my laptop in my cardboard house in the ditch. -2, -1. -1, -3. I try to make one dot. -1, -3. And it like does 3 or 4 different dots at one time. Look, there's 2 dots. No, I just can't do anything right today. 0, -5. 1, 2, 3, 4, 5. 1, -7. That's all we can get on there. What if we wanted 1 right here? What would we have to plug in? 0 for what? Plug in 0 for y, and that's what we're fixing to go into today. But you're going to get -2/5 or 5. You're going to get -5/2, which is -2.5. 1, 2, so right in there would be that one. But anyway, you can take your handy dandy line maker now, and we'll make our line red. There's your line. Now, besides making up new problems, it shouldn't be that difficult. Let's try it again. Negative 1/2 times parentheses plus 3. I'm going to draw this. I'm going to make it a little bit shorter and squattier. And I'm going to copy it. What's the difference between copy and duplicate? Ooh, I like that. Doop, doop. Y'all are impressed, aren't you? Go buy myself a McDonald's milkshake after this. I was able to duplicate. There we go. And we plug in a negative 4/1. Negative 2/1. Zero. 2/1. And 4/1. Now, why am I doing the 4/1? Well, to make everything a fraction so you can see it better. Be able to cancel. So what's negative 4 over negative 2? Positive 2, Hubert. Yes. And that's 2 plus 3 is what? 5. What's negative 2 over negative 2? 1 plus 3? 0 plus 3? Now you see a pattern. 5, 4, 3, 2, 1. Good job. So now we take our handy dandy notebook. Negative 4, 1, 2, 3, 4, and positive 5. 1, 2, 3, 4, 5. Sesame Street. Negative 2, positive 4. 1, 2, 3, 4. 0, 3. We're all on drugs today. 1, 2, 3. 2, 1, 2. And I can't read that. 2, 1, 2. And 4, 1, 2, 3, 4. And 1. What should all of your points do? Good job. If they don't line up, that means you are a failure. Good job. There's your line. Now tell me how hard that is. That's not. It's not hard. Let's do a couple more. Let's do a couple more fractions because y'all suck at those. So we're going to do a couple more. I wish I didn't have to write all this again. Huh? All right. So let's do a couple more fractions. What'd she say?
You can't be a social and take it a bitch.
Okay. All right. I won't say it no more. Y'all gonna turn me in. Put on Rate My Professor. He calls me a loser. He says I'm gonna live in a box. In a ditch. I'm offended. Y is equal to, all right, here we go. 3/2 x plus 6. And y is equal to negative 5/2 x minus 1. Duplicate. Well, it didn't duplicate, did it? Y'all need some vitamin C. Oh, coffee.
You were coughing last week.
No,
Yeah.
I'm the master of this universe. I can do what I want to.
You keep on drinking. Go ahead.
Yep.
Your big drink.
Oh, shoot. Have y'all done the second one yet? Okay, I'm going to change it. Because that's the same problem. I'm going to change it to 1 over 1 over, I'm sorry, I can't hear you. 1 over 4. Did y'all hear anything? I didn't hear anything. What numbers we're going to use over here? Negative what? Negative 8. Negative what? You're trying to whisper on me. I don't want to whisper. 0. Skipped 1. 8's down here, yeah? 4. Good. Multiples of 4. Give you a couple more minutes. All right, what goes in the first one? Negative what? Negative 4 over what? 4 over 1. Negative 2 over 1. 0. Which you could put 0 over 1, which comes 0. You don't have to do that one, but 1 over 1 and 2 over 1. That's supposed to be a 2, I'm sorry. Two over 1. Got to have multiples of the denominator. I don't want a fraction. All right, somebody tell me what negative 4 times 3 over 2 is, or what's negative 3 times, positive 3 times negative 2, or whichever. What do you come up with? You come up with negative 6, right? Okay, what's negative 6 plus 6? 0. What is negative 3 plus 6? What? 2's cancel, right? That's why we make these the way we're making them. So what's negative 3 plus 6? You owe 3, you have 6. You owe $3. You have 6 in your pocket. You positive 3. What's 0 plus 6? What's the pattern? Count by 3. 0, 3, 6. Check the last one. 2's cancel. That's supposed to be a 4, isn't it? Sorry. 4. 4 times 3 is 12. 6 plus 6 is what? 12. Plot that. Really? Here we go. So -4 and 0. 1, 2, 3, 4. -2, +3. -2, +3. 0, 6. 1, 2, 3, 4, 5, 6. That's all we can plot on this one. There's your line. Okay, over here, -8/1, -4/1, 0, 4/1, and 8/1. And what is -8 divided by -4? +2. And +2 minus 1 is 1. What's -4 over -4? 1 minus 1?
0.
And what is 0 minus 1?
1.
-1. What's the pattern? 1, 0, -1. Let's check the last one. What's +8 divided by -4, or -8 divided by +4? -2, Hubert. And what's -2 minus 3? I mean, -2 minus 1. So it checks. So plot that one. -8. 1, 2, 3, 4, 5, 6, 7, 8, and +1. -4 and 0. 1, 2, 3, 4. 0, -1. 4, -2. 1, 2, 3, 4. 1, 2. 8 and 3. Well, 8's way out there, so this is 1, 2, 3, 4, 5, 6, 7, 8, and -3 be right in there. There it is. Now that's 4 problems we did, 1 regular and three fractions. So you should be able to do the fractions. Okay? Now the second method of graphing, you need to turn to your book, your handout that I gave you. And the second method of graphing is called the intercept method. Now some of the stuff that you're going to see with this is graph using the X and Y intercept. Graph using the intercepts. That's the directions you're going to see. Now in your in your handout sheet, you need to put in there that you're going to see directions that say graph using the X and Y intercept and graph using intercepts. Because if you try to plot if it says graph using the intercepts and you try to plot using method 1, you're going to get it wrong. And you're going to come up to me and say, I don't understand why I got it wrong, and it's got the same line in the answer. Well, the reason you got it wrong is you didn't follow the directions. And it will know if you did the right method or not by the points that you plot. Okay? When do you use? You use this method whenever y is what? Not by itself. It says it on the paper. Okay? Well, why would you want to use it? Well, because you don't want to take up time on the test or doing your homework on these problems by solving for y. Okay? Now that's what students do that don't want to learn the methods. They say, well, I just learned method 1 and I just do it for all of them. Yep, and you'll miss half the problems on the test. Okay? You use this method when y is not by itself. The first thing you do is it says on your sheet is draw a table. The table is a bigger rendition of a chart. Okay? So black, draw a big table. 2 sides. On one side, and I'll do it in blue, you're going to do the x-intercept. And you're going to put parenthesis, and you're going to put a 0 in for what? For y. On the right side, I'm going to do the y-intercept. Draw 2 sets of parentheses, or a set of parentheses, and put 0 in for what? For x. Now, the reason we do this method is not to piss people off, okay? Not to make you learn another method. There's 2 reasons to do that I want you to do this method. The one reason is you will understand the concept of y and x-intercept. And 2, no matter what marketing you're in, accounting, anything having to do with statistics, anything having to do with number crunching, anything having to do with reports, anything having to do with graphs. If you want to find out where the line, your graph, is going to cross the x-axis, you plug in a 0 for what? Y. If you want to find out where that line that you're producing is going to cross the y-axis, you plug in 0 for what? No matter what math you're in, no matter what application you're in. You can be in economics, and if the teacher asks you, how are we going to find out where this line crosses the y-axis? You're going to say, plug in 0 for x. I don't care what application. It doesn't matter. And that's the reason we're doing method 2. We're not doing method 2 to make you mad. We're not doing method 2 to make you learn another method. We're doing method 2 to show you a concept. And that is the concept of the y and the x-intercept meaning something. All right? And in business, it means a profit or if it means a loss, pretty much. Now, what do you do now? Well, our example, I don't have a place to put example, but we're going to use this example. 2x plus 3y is equal to 6. That's our example. And the reason I know it's my example is because y is not what? It's not by itself. My bad. What do you notice about the way I wrote the problems down? I want to take a stab at it. Do you notice how I wrote them? I wrote them where the number we got to plug into is directly above what? Where we got to plug it in. Why did I do that? Something I've done ever since I was a student.
To help you see it better.
Help you see it better. So now we're going to plug in what?
Chug.
Plug and chug. 2x plus 3 times 0 is equal to 6. Two times what? 0 plus 3y is equal to 6. I can't discern whether that's a hiccup or a cough. Which one is it? Hiccup. Dadgum, you just brought lunch with you, didn't you? I love Chinese food. I could eat Chinese food. I love Chinese food. Okay, I'll shut up. All right, now, what happens to the zero terms? Is that a coincidence, or is that something that you think is supposed to happen? It's supposed to happen. Where did you get that shirt? How do you know Coop? How do you know him? Huh? He used to work on our farm. I just saw that. Crazy? God, he was crazy. No, he was crazy. He worked on our farm when I was 10, 12, 13 years old.
Wow.
He was crazy. 2x is equal to 6. Small world. That just blows my mind. I ain't thought about that name and I don't know when. 3y is equal to 6. Divide by 2. Divide by 2. He used to live down there on Fence Street. X is equal to 3. Now what do you think we're going to do with that 3? We're going to take it and we're going to put it right there. Ain't that neat? And then y is equal to 2. And what do you think we're going to do with that 2? We're going to take it up here and put it right there. And now, how many points do you have to plot? Now, a lot of people say, well, why'd you put x-intercept up here and y-intercept up here? It's because 90% of the people that do this problem correct, 10% get it wrong because they plot the wrong what? They plot it on the wrong axis. They plot the wrong point on the wrong axis. So that's why you put x-intercept up here and you put y-intercept right here. Now, let's take our handy dandy pen and shrink this down. Really, I swear. There. Sorry about that. I have conniptions every now and then. All right, y'all with me? Now let's take out our handy dandy virtual grid. Where is that thing? Let's just kind of make it as big as we can. Now since this point is in blue, I'm going to make a blue point. And which axis is it going on? X-axis. So 3, 1, 2, 3. And then my green point, I don't have a green point. I'm going to have to make a circle with a pen. Is on what axis? There's that point. Don't look as good as the blue one, but. And our line is going to go through those what? Those 2 points. Now, why you got to be careful on this method? Why is method 2? Why do you have to be very careful on method 2? Well, how many points make up a line? 2. How many does it take to mess up? 1. So you have to be very careful on the intercept method.
That's why you had said earlier, put the x-intercept at the top and y-intercept at
That's why you put it right. See, I put it over here. I wrote intercept, x-intercept here, 0 for y. And I put y-intercept here, 0 for x. Always write which one it is up here so you know which axis it goes on. Yes?
I know I'm late, it's not helpful. What are you given to get this? You're given the blank and the two.
You're given, you're given this right here. This is the example right here. Oh. Do you have your handout with you?
Yeah.
Okay, look on there. It should have an example like this one. And that's what you're given. And it'll say graph using the what? Using the intercepts. Or it'll say graph using the x and y intercept.
Are you using the same number?
It may be a coincidence, but I just made this one up. What does that one say?
The same?
That's just a miracle. Let's just let's do another one. I mean, I didn't know it was that one. I'll do another one though. Y'all got all this one? All right, let's do another one. Let's do. This is the graph using the intercepts, and I'm going to give you 5x plus 2y is equal to 10. All right, that's the problem. So you need to make a big table like I did. Put your x-intercept on one side and your y-intercept on the other. Line it up, put the problem up under it, and then take off. Old coot. Used to wear an eye patch. Huh? Yep. Had in one of his eyes, I believe, if I remember, he got stabbed in the eye, didn't he? Yep, there was about 3 or 4 guys that worked on the farm, and I remember all of them. Taught me a lot. All of them taught me a lot. One of them taught me how to do a lot of mechanicking. The other one taught me how to drink. No, I'm just kidding. No, I'm just kidding. That's a joke. That's a joke.
Okay.
No. But I learned a lot during my teenage years from the people that worked on the farm. How old did he? How old was he when he died? You remember what year it was? Around what year? He just has passed. How long? A year, 6 months, 2 months? Oh, I hate that. He just died of natural ailments, or always smiling. Only man I ever seen smoke rabbit tobacco. Yep. He's crazy. I don't know about that, but he just decided one day he was going to smoke rabbit tobacco. It smelled like cinnamon buns. It did. I don't really know if you could smoke it. I hope that wasn't one of the reasons he passed away, but. He didn't like snakes either. Oh yeah, it's a whole lot easier to do stuff now that I can duplicate. Yes, ma'am.
How are you putting it at the same you're going to put the
Okay, whenever you plug in, we walked in like x-intercept and y-intercept. When you plug in, when you get to x-intercept, plugs in 0 for y. It's always the opposite. Plug in y-intercept, 0 for x.
So it's gonna be 5 and
So
2.
you're going to put that in, 0 goes in for y. You're going to do the math. 5x is equal to 10. 0 goes in for x, and 2y is equal to 10. You plug it in. That's the only part you missed, I think. And when I taught that, Jan, I said that the reason we teach it because it's in all applications. If you ever want to find the x-intercept on a graph, you plug in 0 for y. And if you ever want to find the y-intercept on a graph, you plug in 0 for what? X. Now, right after you do these two things, that's when I take the equation and what I do, I line it up to where the y and the x is right up under what? The 0. Because then you could just look at it and say, oh, I got to plug in 0 for what? For y. And I got to plug in 0 for what? X. And when you do that, what happens to that term? It cancels. Okay, so technically, some people just cover it up with their pencil. That's the short way of doing it. That goes out and that goes out. So now you got 5x is equal to 10. And x is equal to what? 2. And that 2, it's right there. That goes out, you're left with 2y is equal to 10. Y is equal to what? 5. And now you graph those 2 points. All right, we'll highlight this one, green. That's the x-intercept. And we'll highlight the other one, pink. Well, we got a kind of a mauve here. We'll use that mauve. All right, so we pull up our handy-dandy graph. No, handy-dandy virtual graph that we carry around all the time in our pocket. And my green point goes where? On the what axis? The x-axis, so 2. There's my green point. And then my magenta point, or it doesn't say pink, but it looks more like a mauve, is on the y-axis. Ah, did I hear a light go off, or a bell, or something? Light bulb? Ooh, that's awful. How about doing a straight line, Hubert? Now there is a way to check this. How do you check it? Well, pick a point. Well, to check it, you pick a point. I will always pick x is equal to 1. Why will I always pick that point? Because it's easy what? Easy math, Hubert. Yeah, that's right, class. 2. I'm sorry. I'm back in the last problem. So 5x. I just can't write. 5x plus 2y is equal to 10. And what am I going to plug in? I'm going to plug in 1 for x. And solve for what? Good. How did I get rid of a 5? Subtract it. So subtract 5 here. Subtract 5 here. And that's going to give you 2y is equal to 5. Divide by 2. And what do I do with that 5 halves? Goes in the y spot. So we got a checkpoint of 1 and 2.5. So I'm going to take my handy dandy highlighter and we're going to color this blue or aqua. Let's color it blue. And we're going to go 1 and 2.5. 1. Oh my gosh, look at there. What did we hit? We hit the line. So the check tells you that what? You're good to go. All right, let's go back through. The green, plug in 0 for what? Okay, the highlighted green up there. Plug in 0 for what variable?
Y.
Y, because it's the x-intercept. What happens to the y term? Cancels. Leaves you with 5x equals 10. Divide by 5, x is equal to 2. 5x plus 2y is equal to 10. Under the pink, we plug in 0 for what? X. That leaves us with 2y is equal to 10. Divide, y is equal to 5. There's our 2 points. We draw the line. We need to check it. How do you check it? You pick a point. You can pick any point you want to for x, but I'm picking 1. Plug 1 in for x. You get 5 is equal to 5 plus 2y is equal to 10. Minus 5 on both sides. You get 2y is equal to 5. Divide by 2. Y is equal to what? 5 halves. And then this right here checks. When would it not check? Well, let's say you do your check and you get 1 and negative 6. 1 and negative 6. Does that hit the line? No. Okay, let's do one more. Y'all ready? Three. Oh, let's throw a negative in there. Negative 3x minus 4y is equal to 12. That's what you're going to be given. And the directions are going to say graph with using what? The intercepts. Yes, sir. Well, that's why I was letting you know. Yeah, that's it. All right, thanks. All right, thanks. All right. So, plug that in, and we get, what happens to the, bye-bye. What happens to the X term? Goes out, and the Y term goes out. And that's going to leave us with negative 4y is equal to 12. And negative 3x, oops, can't write. Negative 3x is equal to 12. Divide by negative 3. Divide by negative 3. And x is equal to what?
4.
What?
Negative 4.
Good. Negative 4, and that negative 4 goes up here. Divide both sides by negative 4.
Negative 3.
Good job. Y is equal to negative 3. And that negative 3 goes right there. Now plot it and look for a checkpoint. So I'm going to make my highlight, go with the green again. And where does the x-intercept go? On the what? X-axis. 1, 2, 3, 4. Negative 3. Make that blue. Oh, wait a minute. That's the wrong one. There we go. Blue. And it goes on the y-axis. So I got me a line. That's not what I want. All right, there's my line. Now, what point am I going to pick 90% of the time? To check, I'm going to pick x is equal to 1. All right, so here we go. -3, parentheses, 1, minus 4y is equal to 12. How do you get rid of a -3? You add 3, right? -4y is equal to what? 15. Divide both sides by -4. And y is equal to, well, that's going to be 3 and what? 3/4, 3.75. -3 and 3/4. And that -3 and 3/4 goes right here. So what do you do after you find out that your checkpoint is 1 and -3 and 3/4? You plot it. So let's take our handy dandy highlighter and we're going to make this magenta. And that will be positive 1, 1, 2, 3, and about 3/4. Look at there. What did we hit? We hit it. So that checks it. And now you know how to do the intercept method because you got 3 problems. No, wait a minute. 1, 2, 3 or 4. 3 or 4. I can't remember how many we did. And you got one on the same one on your example.
You did a total of 4.
4 today?
Mm-hmm.
Okay. What time is it? I can't see the time right now. 1:57. That's good enough for today because I don't want to try to teach another method. The third method we'll teach Wednesday, okay? All righty. Y'all did a good job today, no matter what anybody says. You bring Chinese food again, I want some. I love Chinese food. I tell you one thing, we had a Chinese